Hi dear participant, welcome to 5-day online workshop. I am Amaresh, assistant professor. So in this video, we will talk about factor analysis and we will solve one example based using SPSS software. Okay, so first we will see what is factor analysis and its details. The essential purpose of factor analysis is to describe, if possible, the covariance relationship among many variables in terms of few underlying but unobservable random quantities. Okay, so these few underlying unobservable random quantities are called factors. Okay, so a factor in this context is equivalent to what is known as a latent variable, which is also called construct. Okay, so it is a latent variable. Okay, oh, a latent variable is a variable that cannot be measured directly. Okay, so the variable that cannot be measured directly, but it is measured indirectly through several observable variables. Okay, so these the variables directly we cannot measure, but can be measured through some observable variable. Okay, a frequent source of confusion in the field of factor analysis is the term factor. Okay, so this it sometimes refers to hypothetical unobservable variable, as in the phrase of common factor. In the sense, factor analysis must be distinguished from component analysis, since a component is an observable linear combination. We have seen the principal component analysis. In principal component analysis, the component is an observable linear combination. Okay, so the p1 p2 so on. So those principal components are the linear combinations of observable quantities. Okay, so but in factor analysis, the we have measuring the unobservable variables. Okay, so these unobservable variables are latent variables or underlying factors. Okay, so the another difference between factor analysis and principal component analysis is that in PCA we focus on explaining the variance structure of the data, but in factor analysis we are concerning about the variance covariance structure. Okay, so we are here mainly focused on the covariance structure. Okay, so next is this. In factor analysis we have a factor model. Okay, so this is the equation of a factor model, in which the where x1 and x1 x2 x3 so on xp represents the original variables. Okay, so these are the original variables. Mm, we have p original variables here and the coefficients. Okay, so the aj1 aj2 so on ajm are called factor loadings. Okay, so these are all the factor loadings. Okay, and these we are estimating these factors. Okay, so these f1 f2 f3 so on fm. Okay, f1 f2 so on are the m uncorrelated common factors. Okay, so these m uncorrelated common factors are less than the original variables. It means the m common factors are less than original variables. And last is ej is a specific factor. The specific factor is iid, that is independently identically distributed with zero mean. So next is the proportion of variance of jth variable contributed by m common factor is called jth communality, and the proportion due to specific factors is called a specific variance. Under the factor model, assuming linearity, each response variate is represented as a linear function of small number of unobservable common factors and a single latent specific factor. Okay, so the common factors are generate the covariance among observable responses, while the specific terms contribute only to the variance of the particular response. Okay, so if variables are uncorrelated factor variables, the factor analysis will not be useful. It means the variables under the study should be have some correlation among themselves. Next is the factor analysis is done in two parts. The first solution is done by placing some restrictions, and then final solution is obtained by rotating these solutions. Okay, there are two most popular methods available in the literature for parameter estimation, that is the principal component analysis, not principal component method, and the maximum likelihood method. We are going to, I will show you these principal component method and maximum likelihood method in SPSS software, and we will use the principal component method to solve for the to estimation of estimation of factors. Okay, these, and it is always prudent to try more than one method for solution. Okay, so the example for factor analysis, if we were interested in measuring the intelligence, here the intelligence is a latent variable. It means it is the unobservable variable. We are going to measure that. For that we could measure the people on several observable variables. Okay, so several observable variables, or if you are interested to measure the intelligence, we have to take the observable variable as writing, reading, and comprehensive skills. Okay, so these readings should we have to take, and based on these observable variables, we are going to estimate the intelligence. Okay, so we will take one example here. So this is the one sales data on salesperson. So here our question is to the manufacturer company is interested in identifying the determinants of a successful salesperson. Okay, so the manufacturer company wants the determinants, identify the successful salesperson. The company has this information, and have assigned weight as x1, height as x2, so on, IQ as x7. Okay, so our interest is to identify the determinants of a salesperson. Okay, so the companies wants the identification of determinants of salesperson. So for that we will use factor analysis in we are going to analyze that for factor analysis. Okay, so I will copy this okay, so then we have a variable view here. We have to edit these variable names. Okay, so then go to data view, and for factor analysis we have to go to analyze and dimension reduction, and then factor. Okay, so control A, select all, and drop these variables into variable box, and in descriptive select the univariate descriptives. It will shows the mean and standard deviation of the each variables, and in correlation matrix select the coefficient and significant levels, and select the KMO and Bartlett test of sparsity, and then click continue. In extraction in so I had told you we have so many methods for parameter estimation of these factors. So this is the maximum likelihood method, and this is principal component method. Okay, so the most popular method are these two. So in this example we are going to analyze we are going to extract the factors or parameter estimation by using principal component, and in select correlation matrix here, and display this. Okay, so we in the extraction we have to extract the eigen values greater than 1. Okay, so then click continue. In the rotation we have to select varimax. Okay, so this is the most popular method for rotate factor rotation, so that we have to select this. Then click ok, the continue, and then click ok. So this is the output of factor analysis. In the first we have a descriptive statistics. It means in descriptive we have mean and standard deviation of each variables. We have 7 variables here. These 7 variables have each 14 observations. This is the end, 14 observations. So then look at the correlation matrix. In the correlation matrix we have p values here, and we have to compare these p values with the alpha, that is the level of significance. The level of significance is 0.5%. It means 0.05. We should have p value less than 0.05, then it is significant at 5% level. Okay, so this is significant, and we have these two significant, this is significant, and this is also significant. Like that we have majority of the variables. These variables have correlation with high correlation. So we have to continue with the performance, and we'll continue with the factor analysis. The next is KMO and Bartlett test. So in the KMO test, the values nearer to 1, the higher values closer to 1 is needed for the better result of factor analysis. So in our for our data we have 0.56. Okay, so next it is the Bartlett test of sparsity. So in the test we can see that this is the calculated p value. We have to compare this with alpha, that is the level of significance. We have it is less than 0.05. So the test is significant, and we can continue with the performance. Okay, so Bartlett test and the KMO test shows the significance. Okay, next is cumulalities. Okay, so these cumulalities measures the percentage of variation in the original variable that is captured by combinations of factors in the solution. Okay, so in this we have all the variables have more than 0.86, that is 86% of 86 percentage. So in our so these three factors seems to capture underlying dimensions involved in the variables. Okay, so we have extract so coming to the total variance explained in the initial. So we these are all the eigenvalues and the percentage of variation explained, and this is the cumulative percentage. Okay, so we have to look for eigenvalues greater than 1. Okay, so the greater than eigen 1 values are first three eigenvalues have the greater than 1 value. So these will explain, the first three will eigenvalues will explain the 94 percentage of variation in the data. That's good. Okay, so next the component matrix. So the it is the factor loading or component loading, and it is a correlation between a specific observed variable and a specific factor. Okay, so the high values means closer relationship, and they are equivalent to standardized regression coefficient as in case of multiple regression. Okay, higher value is the better. Okay, so near to the we see that three components are extracted here. Okay, so coming to the rotated component matrix. So this depict the relative importance of each variable with respect to particular factor. Okay, so this will repeat, it gives the relative importance of each variable. Okay, so we can also, so we can see the x4 and x5 and x6 have the got most have got a high positive values here, and in the second component we have x1 x2 got the most highest positive value. In the third we got x7 as the, so we can also sort this and we will sort these by size, and we will get the better understanding of the rotated component matrix. For that, we have to go to dimension and factors. In the options, we have to select sort by size and suppress the values which are less than zero point 0.6. Okay, so we will sort that values, will retain only the highest positive values. Okay, so then continue and click OK. So we can see in the last. Okay, so this is the rotated component matrix. We will compare this with our Excel sheet data, and it will give better idea. Okay, so this is the our original data. The factor analysis as okay, so we can see here in the factor 1, that is the first factor scores the x5. In factor 1, the variables x5, x4, x6 got high positive coefficients or loadings, which means these are all most weighted variables in factor 1. Okay, so in the factor 1, these three got highest weightage. Okay, so similarly in factor 2, x2 and x1 got high positive coefficients, and in factor 3 we have x7 and x3. Okay, so x7 and x3 have high positive coefficient. It means we can also see in that these 7 original variables are now can expressed in the terms of few underlying factors, that is 3 factors. And so the 7 variables has been grouped together to represent a particular aspect of a salesman. Okay, so in the salesperson maturity revealed in, okay, so we can see that x5, x4 and x6. Okay, so these three variables, okay, you can see here x5, x4, x6 has got the most positive values in the first principal component. It means these together will tell about the maturity of a salesperson. It means the age, number of children and size of holdings related to that particular aspect. So these together will form one the first principle, the first factor 1. The factor 1 will explains this, has weighted these variables are more important. So these more variables are related to what, the salesperson maturity. Okay, so similarly the in the next factor we have x2 and, okay, so we have x1, x2. Okay, so these two factor will have more weightage in the component 2. It means this two factor reveals the physical size. Okay, so the physical size are a physical characteristics of a salesperson. Okay, so these together will form will have more weightage in second factor. Okay, so lastly we have factor 7 and the variable 7 and variable 3. Okay, so the variable 3 and variable 7, it means the education level and IQ level. Okay, so these two will together will give idea about the intelligence. Okay, so the intelligence of a salesperson is revealed by these two variables, that is education and IQ. So this is how we can statistically prove that we can have a better subgroups, and it means the better factors. Okay, so we will see the how to estimate these scores. Okay, so go to analyze and dimension reduction and go to factor analysis. In the scores we have to select scores here and save as variable. We have to select the regression method. Okay, so then continue and click OK. So we will get these scores here. Okay, so these are all the first principal first factor loadings and second factors, and this is third factor. It means it has extracted the Okay, so we can see here, you can see the principal, the three components are extracted. Okay, so these are all the component loadings, and these are all the factors, common factors, or unobservable factors. Okay, so these are all the common factors with respect to, it means in the, we can see in the, in our equation, the f1, f2, f3. So okay, we have estimated up to f3 here. Okay, so this is f1, f2, f3, and these are all the factor loadings. Okay, so factor loadings are these. Okay, so these are all the factor loadings. Okay, this is how the factor analysis will work. Okay, so we can collapse these seven. Okay, so now we see that we have collapsed these seven variables into three factors. Okay, so these three factors, and based on these two factors we have a more information on salesperson. Okay, so it is statistically proved that we can group these variables it according to its importance. Okay, so this is all about the factor analysis. Thank you.